Sliders are also great for playing around with constants and functions to figure out what kind of difference it makes on a function. Let's try a couple of examples over here. So this kind of overlaps the solutions video a little bit, but now we're testing quadratic expressions. So in the equation above, c is a constant. If the equation has exactly one solution, what is the value of c? So again, when we have two sides of an equality, we could basically consider those to be different functions, and we're looking for the intersection. So on one side, we have 4x squared plus 12x, so that's 4x squared plus 12x, and then we have c, so y equals c. And we're basically looking for, so it says it has exactly one solution, so we need this to only have one solution. We can set c as a slider. Equals, and then some number. So we'll start off with c equals -9. And then we have y equals c. If we zoom out, we could see that is the line y equals -9. And that actually is where they intersect once. So that is our correct answer over there. If we didn't get it on our first try, we could just keep checking those, right? So we have -3 perhaps could be our value of c. If we change c to -3, we see that that intersects our parabola twice. So that would be two solutions, not one solutions. Now we could also see over here if it has more than one real solution, right? So this is another quadratic function set equal to 0 now. Again, when we have it set equal to 0, that's basically the line y equals 0, which is our x-axis. So we're looking for intersections with the x-axis. So if it has more than one real solution, again, we could just type in our function. And that gives us 9x squared plus bx plus 49. And so when b equals 1, there's our parabola over there. And we can move that around, see what kind of different functions we get. Ultimately, we want this to intersect the x-axis. And you can see over there, very minimal movement, but it's starting to go down. So we're probably going to need to adjust this. Let's make it as high as 100 and as low as -53. Or let's make it -60 so we can swing that. So we can move this across the entire range here. We could try 7 and 21. So 7, nope. And then 21, nope, doesn't quite get there. But we could go the other way, and we see we're getting up. There's the point where it has more than one solution, right? And more than one solution means it intersects the x-axis more than once. So we can try 42 over here. So that's where it has one solution. So we know that more than one solution is going to be greater than, or more negative than 42. So we could see at 53. Yep, that definitely has more than one solution. Let's take it a step further. So we could have equivalent functions over here, x squared plus bx plus 10, and x minus 3 squared plus c. They're equivalent. So we could see what we have to do to make those graphs equal each other. So we have x squared plus bx plus 10, x squared plus bx plus 10. And then we have x minus 3 squared plus c. X minus, and then let's do 3 squared plus c. So we have another slider there, right? And we can play around with these, try to get them right on top of each other. And there we go over there. Didn't even have to play around with c. b equals -6, c equals 1. And we can just zoom in, make sure those do, in fact, overlap each other fully. And it looks like they do. So -6 plus 1 is -5. We could do something like this over here as well. We have the graph of y equals 2 to the x minus a. So we'll clear these. 2 raised to the x minus a. We add our slider in. And again, we'll find some key points to identify. It looks like this has a y-intercept at 0, -3. So that's what we want. And our a values range from 1 to 4. So we can slide from 1 to 4. And again, we want an x-intercept at -3. So not at 1. Here we go. And that looks to be about -3. We can click on it and get our y-intercept, 0, -3. That's correct. So the a value is actually 4.